Hi, GCP 1 hour crash course. This course is ideal as a refresher for professional cloud architect exam, or if you are starting on a GCP journey, or if you have worked on AWS or Azure and looking to get a comparative study from GCP. I'm Ashutosh Mishra. In terms of the resources, Google documentation is the best. Google has done a really good job in terms of defining its products, categorizing them, putting a lot of associated documentation, use cases, tutorials, and training for each one of the product. And above all, it has done a really good job in terms of linking different products and linking the documentation. There's a proper synergy or synchronization between documentation links. And also, it has done a really good job in terms of introducing new product, but at the same time updating and maintaining the documentation. So always look at the Google documentation. In terms of the GitHub repos, Google has a couple of GitHub repos, and apart from that, there are a lot of GitHub repos. But these two are my favorite ones: Google Cloud Platform and the Professional Services. It has a lot of examples that you can use as is. Sort of take a snippet out of it and you can use it for real world example. So let's get started. In terms of the Google network footprint, it's pretty impressive. So the Google Cloud, it consists of physical assets such as computers, hard disk drives, virtual resources such as virtual machines, and they are all contained in Google data center. And all of the Google data centers around the world are interconnected by the Google network. This is the same network which provides and user services like Maps, Gmail, YouTube, etc. And this network interconnects with the public internet and more than sort of 90 internet exchanges and more than 100 point of presence worldwide. So as you can see in this map, there are around 24 regions. Four were added recently, 73 zones, thousands of edge nodes, and it's been carbon neutral since 2007. On the left side, this is the so virtualized uh, way of putting a network. So it's sort of it starts with zones, then regions, and then all of your services basically sit inside zone. And one of the important part to note about Google Cloud GCP networks is that they are global. They are not limited to any specific zone or region. You can spin up services as part of the same VPC network all across the globe. Next, look at some of the basic concepts of GCP. So when you're looking to access Google Cloud Platform, you start being a user or a member. So which is basically two types. Either it's a user account, manned account with AD, LDAP, single sign-on, or SAML2 based authentication, or you are an unmanned user, which is more for server to server connection or a connection between different machines, and that's where service accounts come into picture. Then you have some sort of roles defined that what you can do. Google has primarily three types: basic, predefined, and custom. Most of the organizations define their own custom roles. So now, once your identity is confirmed and you have a specified role, what you access is projects. What are projects? Projects are the trust boundary of a scope. In Google hierarchy, at the top is the organization, which is tied to your domain or as the company. Then within the organizations, you have the concept of folders, which is more like a department. So HR department, finance department, or any of the business units, they are more like departments. Now those departments have different teams, and those different teams have different projects. So that's how it's sort of trickles down to. Then all of your resources, they are part of projects. Now, w- once you have all of the resources which are available as part of the projects. Where do you access them? That's where the concept of the network comes into picture. So at the core of it, you have a zone. In this particular example, US East 1B. So what zone is? Zone is one specific data center. Now, within a region, one physical location can have failure. So for fault tolerant use cases, you have another building or another physical location within the same region, and that's basically the concept of zones and regions. And similarly, one entire region can fail because of tsunamis or some other incident. So then you have another region, and this is how Google data centers are spread all across the globe. Now, network is it's sort of a logical or virtualized composition of your services across different zones, across different regions, uh, and within that virtualized sort of layer, you have the concept of subnet, which is further categorizing your set of services as part of a subnet so that you can specify specific firewall rules and other control mechanism for a group of services. Now, once you have located your network and everything, there are primarily four different ways to access Google Cloud Platform. It's through the console, which is console.cloud.google.com. If you are a new customer, you get $300 uh, voucher to actually start free on Google Cloud Platform. Um, then the second way is Cloud Shell and Cloud SDK. Cloud Shell is a browser-based command window which you can activate from your Google Cloud Console, and it also provides you an inline editor where you can actually um, edit your documents or your files or your code base from a browser window. Cloud SDK is the SDK to programmatically connect to Google Cloud Platform from your local machine or from any sort of putty or any window based the terminal based platforms. Then Google Cloud Platform services can be accessed by RESTful APIs as well. And then you have the mobile app on iOS and Android, which you can use it. Now, the general principle of access and controlling security in Google is principle of least privilege, identity, roles, and privileges. And the child policies cannot restrict access granted at the parent level. So, and that parent level is from all the way from organization to resources. Now, let's because Google Network is pretty extensive and it has a lot of capabilities. So if you divide it in terms of sort of capability, when comes to connect, Google provides hybrid connectivity options, which is Cloud Interconnect, Cloud VPN, carrier peering, and direct peering. This is to connect to other cloud platforms, SaaS solutions, or on-prem solutions. Virtual private cloud that includes granular IP addresses range, selection, routes, firewalls, cloud VPN, and cloud router. Then you have cloud DNS, which is a scalable, reliable, programmable, and managed authoritative domain naming system service running on the same infrastructure as Google. Then for connection, it also provides service directory, which helps reduce the complexity of management and operations by providing a single place to publish, discover, and connect all application services. When it comes to scaling, uh, Google provides cloud load balancing, which basically puts your resources behind a single any cost IP. It scales resources up or down with intelligent auto scaling, and it integrates with Cloud CDN. Cloud CDN, which is a globally distributed edge cache to accelerate content delivery for websites and applications. To secure, Google provides Cloud Armor, which works with HTTPS load balancers to provide built-in defense against infrastructure DDoS attacks. Cloud NAT, it enables provisioning application instances without public IP addresses while also allowing access to the internet in a controlled and efficient manner. Network telemetry, which provides both network and security operations with in-depth responsive VPC flow logs for Google Cloud Networking Services. VPC Service Control, which enables enterprises to keep their sensitive data private while leveraging Google Cloud's fully managed storage and data processing capabilities. To optimize Network Intelligence Center, which provides unmatched visibility. It's sort of a single pane uh, to do the proactive network verification. Then the network service tiers, Google provides a standard and premium network tiers. Now, now let's look at the compute resources that Google provides, and we'll be looking at its features and use cases. So the compute resources are Compute Engine, Kubernetes Engine, Cloud Functions, App Engine, and Cloud Run. The way these are differentiated: Compute Engine is infrastructure as a service offering for stateful applications. So you get operating system level control. It supports custom machine types, and it gives you auto scaling support. The use cases are on premises and monolithic workloads, raw compute to meet existing infrastructure requirements. So for most of the lift and shift kind of use cases where you don't want to where you don't want to refactor your application, you move it to Compute Engine. Kubernetes Engine, it's a secure and managed Kubernetes service for Kubernetes application for pods and cluster auto scaling, workload and network security. Where Kubernetes is used is for microservices architecture, hybrid and multi-cloud support, primarily using Anthos. So some of its examples are containerized API deployments and cloud native apps. Now then cloud functions, which is it's a serverless execution environment for building and connecting cloud services. So it's a single purpose event based capability. It supports a lot of different programming languages, and it supports Google Cloud Client libraries as well. It is primarily for event-driven and data processing apps. Uh, something basically to manipulate user-generated data and events. As an example, if you post a comment on a Slack channel following a GitHub commit, then you have App Engine, which is the serverless PaaS offering to run container applications. Um, App Engine has two flavors: standard and flexible. The standard environment supports some standard languages, but with specific versions. What flexible supports is the Dockerized containers. So you can put any programming languages. App Engine is mostly used for sort of stateless applications. So that's the stuff that you need to keep in mind. HTTP service and backend apps, web frameworks, microservices. Example, a lot of the web-based technologies. Cloud Run, which is the managed compute platform to run stateless containers that are invocable via web request or pub/sub events. It's completely serverless. It's built on Knative. It's fully managed or Cloud Run for Anthos. Its use cases are container-based apps and services. Um, it's got industry standard packaging for multi-cloud infrastructure. It's a lot of it's used for a lot of use cases related to the multi and hybrid cloud. Uh, Examples: custom runtime environments such as Rust, Kotlin, C++, and Bash. Legacy web apps using languages such as Python, and containerized apps that need custom hardware and software. Now, then let's look at this compute engine. uh, in sort of in greater detail and all of the capabilities that's available. When it comes to compute engine, it's a virtual machine hosted on Google's infrastructure as a service, public and private images for Linux and Windows servers. You get a choice of virtual CPUs, cores, and memory, boot persistent disk, and other storage options. And then you have the VPC network and subnets. Now, if we look at the compute capability, there's a predefined and custom machine types. Uh, you get general purpose, which is standard, high memory and high CPU. Then you also get memory optimized or compute optimized. When it comes to storage, zonal persistent disk, which are efficient, reliable block storage, regional persistent disk, which are regional block storage replicated in two zones. Then the local SSDs, high performance transient local block storage, cloud storage buckets, which are the affordable object storage, and the file store, which is high performance file storage for Google Cloud users. Now, compute engines also provide preemptible VM instances, which is much lower price than normal instances. But VMs might stop, which is preempt, based on resource availability. So it's ideal for fault tolerant applications, batch processing tasks. Always stops after they run for 24 hours, and there's a 30 seconds preemption signal. Shielded VM, which is Shielded VMs offer verifiable integrity of VM instances, such as Secure Boot, Virtual Trusted Platform Module, uh, which enables measured boot and integrity monitoring. It also provides you confidential VMs. Confidential VMs allow data encryption in use while it's being processed. Instance template, which is very important, it defines the machine type, boot disk image, or container image labels, and other instance groups. It's used to create managed instance groups or to create individual VMs. Managed instance groups are very useful for scaling requirements, and anywhere you need the system to auto scale, they basically use managed instance group to spin up identical VMs. Then the VMs can be accessed from Linux or Windows. Linux, SSH access, GCP console, third-party client, terminal clouds, Cloud Shell via Cloud SDK, as long as the firewall rules are there. Windows, you can use RDP access on 3389. You can use PowerShell terminal and the third-party client. Then you have live migration for VMs available. Live migration to keep VMs running even when a host system event such as software or hardware update occurs. Compute Engine live migrates running instances to another host in the same zone instead of requiring VMs to be rebooted. Apart from that, you also have sole tenancy nodes. A sole tenant node is a physical compute engine server that is dedicated to hosting only your project's VM. So, like you can see in this example, this is a multi-tenant host, and in case of sole tenant host, it will be only your a particular customer's VM that will be hosted. This is very useful for some of the really secure environments. Then, in terms of networking, it supports regional HTTPS load balancing, network load balancing, global and multi-regional subnetworks, inbound, outbound firewall rules. Pricing, it's got a per second billing. You also get commitments savings, and then you also get sustained use savings. Now, let's look at all of the storage solutions. When it comes to storage use case, and if you follow the use case, you have a use case of storing everything. Um, anything uh, in terms of any object. So then the option is object or blob storage, which is the cloud storage. It's a reliable object storage with global edge caching and instant data access, ultra low cost archival storage with online access speed. It's ideal for stream videos, image and web asset libraries, data lakes. For data lakes, cloud storage has been sort of one of those premier choices. Backups, media archives, long tail content, and to meet regulation or compliance requirements. Then you have a use case of storing for a machine or an application. So that's where the block storage comes into play. So you have persistent disk or the local SSD. Persistent disk, which is high performance block storage for virtual machines and containers. Local SSD, which is for ephemeral locally attached block storage for virtual machines and containers. Persistent disks are ideal for disks for virtual machines, sharing read-only data access uh, across multiple virtual machines, rapid, durable backup of running virtual machines, and it's also used for storage for databases. Local SSDs are ideal for flash optimized databases, hot caching layer for analytics, so depending upon the level of IOPS you need. Then there is a use case of store for sharing between applications. And for that, the option is file store, which is a fully managed scalable file storage with predictable performance. It's ideal for data analytics, rendering and media processing, application migrations, web content management. Then you have a use case of storing for mobile, uh, which is for mobile applications. The option is cloud storage for Firebase, scalable storage for user-generated content from your app. It's ideal for user-generated content, uploads over mobile network. Then you have a use case for moving services, and that's where you look at using data transfer services, which is a fast, offline, online, or cloud-to-cloud data transfer. It's ideal for collecting research data to move machine learning and AI training data sets and also migrate from S3 to Google Cloud. And then the last option is the workspace artifact storage, which is more of the collaboration side. So the Google Workspace Essential, which is a cloud-based content collaboration and storage. It's ideal for access files from anywhere through web app and sync clients, create and work on documents with coworkers, so Google Sheets, Google Drive sort of thing, and then connect to your team with secure uh, video conferencing. Now let's get deeper into storage, which is basically cloud storage. Cloud storage, it's an object storage for companies of all sizes. You can store any amount of data, retrieve it as often as desired. It has unlimited storage with no minimum object size, worldwide accessibility, and worldwide storage locations scalable to exabytes. Low latency, time to first byte in milliseconds, high durability of 11 nines, and geo-redundancy if the data is stored in a multi-region or dual region. It provides you a single API across storage classes. Now let's look at its characteristics. Storage uh, storage has four storage classes: standard, nearline, cold line, archive. Standard, which is meant for hot data; nearline, which is low cost, and the data can be stored for at least 30 days. Cold line data for at least 90 days. Archive for at least 365 days. So because it's basically based on the usage, the frequency of data uses. Accordingly, you can see the retrievable cost is going down. So it's zero point zero 0.01. Sorry, the retrievable cost is going up 0.01, 0.02, 0.05 cents per gigabyte. For a standard, it could be regional or multi-region or dual region. The availability starts going down as well. So multi or dual, you have 99.95% availability. For nearline, 99.90. For code line, almost similar, 99.90. And for archive, there is no SLA. Similarly, the price you can look at is that the storage cost is going down because you retrieve it less frequently. Now, what's the structure of a storage? A storage has buckets. Buckets are global unique names. They support object lifecycle management. You could do directory synchronization. It has a very strong consistency, customer managed supplied encryption key, and you can provide bucket lock, which is configure a data retention policy. So storage has buckets. Buckets store objects. Objects are immutable. It supports object versioning. No minimum size, unlimited storage, can be moved from bucket to bucket. Object holds, you can place a hold on an object to prevent its deletion. Object lifecycle management, you can receive PubSub notification if an object has been modified. And then you have cloud audit logs. So storage has buckets. Buckets store objects which are accessed by there are different ways to access it. GSUtil command, RESTful APIs, GCP console, and the access is controlled by Cloud IAM, which is it controls access to buckets and objects. ACL access control list, signed URL, so you can get a valid key access to objects and bucket via cryptographically signed URL, which is the which is time limited. And access is also controlled by signed policy document. Now let's look at network. VPC networks, including their associated routes and firewall rules, are global resources. They are not associated with any particular region or zone. Zone is similar to a physical data center. Within a region, you have multiple zones. Subnets are regional resources. Each subnet defines a range of IP addresses. Traffic to and from instances can be controlled by using firewall rules, and routes and firewall rules can be set up between different regions. Routes define paths for packets leaving instances, and instances can use VPC routing to connect to the internet. Similarly, you can set up VPC network peering between two different VPCs. VPC network peering allows internal IP address connectivity across VPCs because traffic stays within Google network and it provides you low latency. Now let's look at App Engine. App Engine is a fully managed serverless platform for developing and hosting web applications at scale. App Engine provides you two options: App Engine standard environment and App Engine flexible environment. If your use case require you to use one of these languages with predefined and pre-configured uh, runtimes, uh, you can use App Engine standard environment. It gives you 1 GB of data storage and traffic for free, which can be increased by enabling paid applications. But if your requirement is you need a custom libraries and package runtime environment, which is basically using the Docker containers, you can use App Engine flexible environment. What it provides primarily is the customizable infrastructure, so you can SSH for debugging. It provides you performance options, native feature support, such as microservices, authorization, SQL and NoSQL database traffic splitting, logging, versioning, security scanning, and content delivery network. And as well, provides you managed virtual machines. Now let's look at the Kubernetes Engine. Kubernetes Engine is a portable, extensible open source platform for managing containerized workload and services that facilitates both declarative configuration and automation. So as part of Kubernetes open source architecture, primarily there is a control plane and then you have nodes. Nodes have pods and pods run containers. As part of the control plane, you have control managers. cloud control managers, API server, scheduler, and etcd, which is the distributed key value store. So along with all of these components, what Google provides is its connectivity, native connection to all of Google services in terms of VPC networking, persistent disk, load balancers, and cloud operations. So what makes GKE a very comprehensive service or product to manage Kubernetes cluster is this entire control plane, which is upfronted by API servers, resource controllers, scheduler storage. Then you have the concept of nodes, and it has native integration and the capability of a very robust network, storage, load balancer, and operations, which is monitoring part of it. Let's look at load balancer, which is very important. Load balancer distributes user traffic across multiple instances of application. So as in this picture, it takes the user request and it routes it to different backends depending upon the request. It supports layer 4 based load balancing to direct traffic based on data from network and transport layer protocols. And then it also supports layer 7 based load balancing to add content based routing decision based on attributes such as the HTTP header and the uniform resource identifier. Balancers can be divided into external and internal load balancers. External load balancers where traffic is coming into Google, external HTTPS load balancing, SSL, TCP or TCP UDP network load balancing. Internal ones are internal TCP UDP load balancing and internal HTTPS load balancing. Now, how do you choose a load balancer? And this is one of the really important topic. So if you take an example of internal to GCP traffic, if it is HTTP or HTTPS, you pick HTTPS load balancing. If it is TCP traffic, well, you look at whether SSL needs to be offloaded. If yes, then you pick SSL proxy. If no, then you look at whether it's IPv6 ID. If it's IPv6, you pick TCP proxy. Otherwise, you look at whether the client IP needs to be preserved. If yes, then you look at network TCP UDP. Otherwise, you pick TCP proxy. But if the traffic is UDP itself, you pick network TCP UDP load balancer. When it's internal, if it is HTTP or HTTPS, you pick internal HTTPS. If it is either TCP or UDP, you pick internal TCP UDP load balancing. Now, in terms of transferring data to Google Cloud Platform, there are multiple options. There are options of transfer services to GCP platform. Examples are from S3 bucket, Azure Blob Storage, or any of the HTTP location. Then there are options for transfer services from on-premises, where you can transfer a huge amount of data from on-premises. Typically, these kind of process, they require you a Docker agent to be installed on on-premise Linux machines, and the agent process are dynamic, fault tolerant, and they are part of a pool. And that's the reason you can transfer hundreds of terabytes of data in single transfer. Other option is transfer appliances, is where Google ships you a box and you upload all of your data and you send it back to Google to upload it to your storage bucket. This is ideal for data sizes which are greater than 20 terabytes of data. Then you have an option of Bigquery data transfer service. Bigquery data transfer service, it automates data movement into Bigquery from a lot of different sources. So these are the example of SaaS apps in terms of Campaign Manager, Cloud Storage, and all of the Google Ad ones. At the same time from YouTube as well. Then Amazon S3 or Teradata or Redshift as data warehouses. Now let's look at databases. When it comes to databases, typically we break them into relational, non-relational, and in-memory databases. Relational bare metal used for lift and shift, where you don't want to refactor or program everything. You just lift and shift everything. The typical examples are a lot of databases, pretty much all of the databases. Cloud SQL, it's a managed MySQL, Postgres, and SQL Server. Then Cloud Spanner, which is same as Cloud SQL, plus the horizontal scaling. Cloud SQL does not give you horizontal scaling. Standard Cloud SQL gives you SC transaction, referential integrity. Cloud Spanner gives you all of that plus horizontal scaling. When it comes to NoSQL, you break it into key value pair or the document databases. Cloud Bigtable, it's a cloud native NoSQL wide column store for large scale and low latency workloads. It's really ideal for real time access, large analytical workloads, recommendation engine, fraud detection, ad tech kind of use cases. Firestore, which is a cloud native serverless scalable document store. Firestore real-time database. It's ideal for storing and syncing data in real time. So a lot of use cases are mobile sign-ins, personalized application, or in-app chat. Then memory store, which is a fully managed Redis and Memcache for sub-millisecond data access. It's ideal for real-time analytics, caching, gaming, leaderboards, social chats, or news feed. Then apart from that, Google also provides a lot of partnership with industry-leading databases, which you can access from your Google console itself. Now let's look at a different view of databases. Traditionally, we have looked at databases from three angles: relational, analytical, and NoSQL database. This slide is basically to present you the view of BigQuery, where the BigQuery fits in. So relational databases, as discussed, Cloud SQL and Cloud Spanner. Uh, NoSQL databases like Bigtable, Memory Store, and Firestore. BigQuery, which is an enterprise data warehouse. The biggest plus point of BigQuery is that you don't have to manage any of the infrastructure that underpins the petabit scale performance of BigQuery. Um, as part of BigQuery, there are primarily two parts to it. One is the BigQuery storage service, where tables, which are organized under a concept called data set, which belong to a project, and all of the data is stored in a file system called Colossus. Then you have BigQuery query service, which can be accessed from Web UI, BQ, or REST APIs. And these two are connected through a petabit network, which makes it really, really fast. BigQuery can ingest bulk data as well as the streaming data. On Bigtable also, the Bigtable clusters, so they have tablets and all of that data is stored in the file system called Colossus. In Bigtable, you only get a row key, which is only identifier for the row. There is no other key apart from that. And then everything else is stored in columns. Now let's look at the security part of it. Google has done a really good job in terms of coming up with a security command center, which is a one-stop shop for centralized visibility and control of GCP organization hierarchy. It helps you discover all of the misconfiguration and vulnerabilities from a single pane of glass, and it integrates with Google's security products and partner products. You get cloud asset inventory where you can discover all the assets. You can detect threat in terms of event threat detection, container threat detection, which is in beta. It has security health analytics, which identifies misconfigurations across storage, networking, logging and monitoring, VM instances, GKE clusters, and provides you all of the compliance monitoring. And then it provides you web security scanner, and apart from that, it integrates with binary authorization, which is for container, DLP data loss protection for masking the data and identifying sensitive data, Cloud Armor for SETI. Then, with this centralized visibility, you can view all your assets, you can find all of the security issues, and then you can receive the compliance reports, which helps you take action to remediate and respond faster. Now, let's look at some of the security best practice. When it comes to security, it's all about who gets to do what on which resource and how. So who is always controlled by identity and access management, which is to create trust boundaries in terms of identities and groups, whether it's a Google account or service accounts, resources. So resources specific access permission. It has a very fine grained permission. Roles. It has three types of role, primarily predefined, primitive, custom, and you can apply policies as in JSON specification. Data security, data is secured at rest and in transit. And at rest, AES 256 or AES 128, in transit, TLS version 1.2. The data is secured in terms of a concept called DEC, which is a data encryption key, and and this key sits very close to the data, and uh, all of the data is encrypted in chunks. Then you have key encryption key, which is an envelope encryption on top of DEK, and KEK sits somewhere else. So mostly in the secret manager. When it comes to key management, you can have it managed by Google. DEKs, they store near the data chunk, and KEKs are stored centrally. You can use customer supplied keys, as well as you can use cloud KMS. Let's look at some of the best practices. Authenticate and authorize user with IAM roles always, or use identity aware proxy. Use organizational policy. Identity aware policy proxy simplifies authorization to GCP apps and VMs. Always use a bastion host to provide access to private machines. Only SSH into internal machines. Configure firewall walls. Use Cloud NAT to provide egress to the internet. Secure network with private IPs, firewall, and Google Cloud Private Access. Consider hierarchy inheritance when assigning roles. All internet traffic should terminate at the load balancer. Restrict access to service endpoint to TLS only. In the load balancer setup, only create a secure front end. Use DLP API to protect sensitive data. Allow access to Google Cloud services from VMs that only have internal IPs. Remove external IPs. Use Cloud Armor to create network security policies and mitigate DDoS attack by leveraging Cloud DNS and Google Cloud Armor. Now, let's look at the operations part of it. Google provides a suite of products for performance management, cloud monitoring, which is a full stack monitoring for GCP and AWS. It provides you charts and dashboards, alerts and notifications, and service level objective monitoring and uptime checks. Cloud logging and error reporting, which is to it helps you identify and understand application errors. Logging lets you helps you identify real-time log management and analysis. So cloud logging, log viewer, and then it provides you log-based metrics, and then you can create log syncs, which is manage retention and setup policies. APM, application performance management category, it provides you cloud debugger, which is to investigate code's behavior in production. Cloud trace to find performance bottleneck in production. Cloud profiler to identify CPU patterns and memory consumption. Now let's look at some of the big data components. Dataproc is a managed Apache Spark and Apache Hadoop service. Exactly same as Apache Hadoop ecosystem. If you want to migrate Apache Hadoop ecosystem to GCP, Dataproc is a really good option. Why you would use Dataproc versus Apache Hadoop ecosystem is because it's fully managed, right? Only pay for resources that you use, and they spin up an auto scaling cluster in 90 seconds on custom machines. Apart from that, it provides you low cost, it is super fast, and apart from that, it's well integrated with Google Cloud services such as BigQuery, Cloud Storage, Cloud Bigtable, Cloud Logging, and Cloud Monitoring. It provides you enterprise grade security, so you don't have to spend a lot of time securing your Hadoop cluster, and it containerizes OSS jobs, which is in example like Apache Spark on Dataproc. You can quickly containerize them with Kubernetes and deploy them anywhere a GKE cluster lives. Data flow is a very important services. It's a managed service for executing unified stream and batch data processing that's serverless, fast, and cost effective, and is developed using the Apache Beam SDK. As part of Apache Beam SDK, there's a concept of pipelines where you have source, which could be file-based, file systems, messaging databases, or other sources. It supports windowing, and then it supports triggers. On the sync side, you have again same sort of sync, file-based, file system, messaging, transform, and the other IO services. The way the Apache Beam SDK, Apache Beam pipelines work is that you have the concept of P collection and P transform. P collection represents a distributed data set that Beam pipeline operates on. P transform is actually that operation. So the pipeline is a combination of p-transform and p-collection. You start with a data set, you apply p-transform, and then you store that into p-collection. You again apply a transform, and you again um, store that as a collection. And then eventually you write it into the sink. And this pipeline can be run on multiple runners. Direct runner, you can run it on Flink, Spark, Dataflow runner, Samza, Nemo. So Beam SDK gives you a unified way, and the same code works for batch as well as for real time or stream use cases. This is an example of how do you create a pipeline, how do you create a collection with a read from text, apply transform, then you apply the transformation on the collection, and then you can define functions which are called by using do. Let's look at PubSub quickly. PubSub is an asynchronous messaging service that decouples services that produce events from services that process events. PubSub offers durable message storage and real-time message delivery with high availability and consistent performance at the score. Core concepts. There's a topic, which is a named resource to which messages are sent. There's a subscription. It's a named resource representing the stream of messages. Message is the data itself. Message attribute, a key value pair that the publisher can define for a message in terms of like what's the language tag and all of that. How the PubSub message flow works. A publisher will publish a message to a topic. A subscriber will subscribe to that topic. Once the subscriber uh, has received the message and sends the acknowledge back to the subscription, that message is deleted. Now let's look at another very interesting product called Data Fusion. Cloud Data Fusion, which is a fully managed cloud native enterprise data integration service for quickly building and managing data pipeline. It's powered by the open source project called CDAP. The CDF web UI is used to build scalable data integration solutions to clean, prepare, blend, transfer, and transform data. So if you look at the general anatomy of a big data application is that you have streams of data coming in. You are using different capability, either real time or map reduce as part of batch or Spark, and then it creates different data sets which has acid. Some of those data sets require acid compliance. Now, what CDAP does, it basically provides a graphical way to solve uh, uh, to solve big data application challenges. So on the right side, you can see it provides you a code-free, self-service, UI-driven hybrid and multi-cloud data integration tool. It integrates with Google's big data tools. It has an enterprise-grade security, metadata and lineage integration, and you have built-in connectors for modern and legacy systems. Now let's quickly look at AI platform. So as part of artificial intelligence with the products, uh, Google has a service called AI Platform and AI Platform Unified, which is to make it easy for machine learning developers, data science, and data engineers to take their projects from ideation to production and deployment quickly and cost effectively. New AI platform, Unified. It brings together AI platform, AutoML, and MLOps in one complete cohesive platform. A typical machine learning lifecycle is you source and prepare your data, you coach your model, and then you train, evaluate, and tune your model. Then you deploy your trained model, you get prediction from your model, you monitor the ongoing prediction, and then you manage your models and version. So, depending upon the predictions, you go back and modify your model again. So, AI platform helps you through the journey of machine learning uh, for all of the phases. So it has training service, it has prediction service, it provides you notebooks, it has a data labeling services, and then it also provides you deep learning VM image. Now, let's look at it from the angle of an architect. How do you approach a problem? How do you help clients pick one specific product over another uh, based on the specific use case. So the way architecture process is the architecture design is basically a combination of business strategy, planning, development, and operation. When you look at architecture design, you typically break it into business requirements and the technical requirements. When you break it into business requirements, and before gathering business requirements, you manage the business process. Managing business process is about stakeholder management, change management, and team management, and making sure team is equipped to enable GCP. Business requirement is about understanding high level objectives, so high level vision and objectives, product strategy, and one of the most important thing is to understand the service level objectives. Then you look at application design consideration, which is about the disruption tolerance, implicit cost management factors, total cost of ownership, strategic or tactical consideration, DevOps, DevSecOps, and manage whether you should go with managed services, SaaS, or data life cycle management. The next one is cost consideration, and application design considerations and cost consideration go hand in hand because depending upon the choice, your total cost of ownership or your investment changes. Then you look at system integration and data management, which is basically finding out integration checkpoints, integration investment, whether it's point to point, RESTful, or publisher subscriber kind of model. Data management, what is the lifeline? What is the life cycle management of data? Then you look at security from data confidentiality and data integrity point of view. You look at compliance and regulations. What are the regulatory requirements business has? Then you look at the success measure that at the end, how would you measure the success? What are the different KPIs and what's the projected return on investment? Then you start looking into the technical requirements. Technical requirements are often orchestrated by the technical process, software development lifecycle, ITIL, CI/CD, QA, business continuity plan, or disaster recovery. When it comes to technical requirement, you typically look at it from the angle of functional requirement or non-functional requirement. Functional requirement is about what sort of compute you need, what sort of storage you need, what sort of network connectivity you need. Non-functional is about the availability requirement, which is a measure of the time that services are functioning correctly and accessible to user? What are the reliability requirements, which is a measure of probability that a service will continue to function? Scalability is that if the application can scale. Durability is to measure the likelihood that the stored object will be retrievable in the future. Now, as part of architecture exam, there are three use cases, and there are a lot of questions depend on it. The one is Terram Earth, which is it's a mining and agriculture equipment manufacturing business. The use case is that 20 million vehicles collect 120 fields of data downloaded using maintenance port. They have 200,000 vehicles connect directly through cellular network, and they receive 9 terabytes of data collected for 22 hours of operations. The solution is it's a single US West Coast based data center, Linux and Windows based system gzip files. They have two applications. One is for data ingestion, another one is for reporting. And then the main challenges are the reports are aggregated 3 weeks old. Since data is old, customers are without vehicle for up to 4 weeks. So the proposed solution could be for database, they use BigQuery for data warehouse and advanced analytics timestamp partition. For data processing, cloud data flow for serverless ETL, data flow processes both batch and stream data, replaces Python-based ingestion. ML engineer auto ML tools, forecasting to anticipate stock needs. For vehicle cellular connected device management, they can use Cloud IoT Core. For messaging, Cloud PubSub. For device managing, again, they can use Cloud IoT Core, which can have a flow of IoT devices to Cloud PubSub, Cloud Data Flow to Cloud Storage. They can manage the messages using Cloud Storage and Data Flow Runner jobs. Data visualization, they can use Data Studio, which is connected to BigQuery, and they will partition BigQuery by timestamp, which will allow faster queries on last 30 days. Next one is Modker Game, which is a sort of multiplayer game maker for mobile platform. Their current state is game built using server-side integration, use cloud provider for physical servers, and they use application servers, MySQL DB, and analytical tool. Their challenges being they need to scale it for the global audience, auto-scale reporting databases, auto-scale application server. So the possible solutions they can look at is that the compute engines, as suggested with managed instance groups, HTTPS load balancing with auto scaling, use cloud operations, use cloud data store for transactional game state, use cloud PubSub for buffering of live and late data, use cloud storage for data uploads, cloud data flow for bulk and stream processing, use BigQuery for analytics use cases. And you can refer to mobile gaming analytics platform reference architecture by Google. The last one is Dress for Win, which is a web-based wardrobe management company. Their use cases they want to fully migrate to public cloud, but as a first phase, they were looking at migrating dev and test environment. Uh, they need to build disaster recovery site because current infrastructure is at a single location. So in terms of their solution, what they can do is for databases, MySQL can be moved to Cloud SQL, uh, Cloud Memory Store for Redis. They can use K8 containers or EKS for GKE for microservices deployment, App Engine for application layer auto-scaling, load balancer for high availability traffic routing. They can use Cloud Data Proc in place of their 20 Apache Hadoop clusters. They can use Dataflow for stream and batch processing, BigQuery for analytics, Cloud PubSub for messaging rather than RabbitMQ, Cloud Functions for event triggers. And they can use all of the network capabilities in terms of cloud VPN, customers supplied encryption keys, firewall rules. They can use Cloud Launcher for Jenkins apps Then they can use cloud storage for backups because they have a lot of storage appliances that they are using, and they can use cloud monitoring for logs, image stores, could go in image repository. DevOps, they can look at CI/CD solutions, Terraform, and cloud build, container registry, and Jenkins on VM or containerized deployment. So this brings to the end. I hope this was useful. Take this 1 hour video as a refresher for either moving to GCP or as a prep for Google Cloud GCP Professional Cloud Architect exam. If you're taking the exam, good luck with the exam. Thank you.